Okay, so I'm testing out this streaming setup. This is my first time streaming on Twitch, and I think there might be someone watching, but you're the only person here. But I'm also trying to record this in case I can post some videos of the sessions. So my plan is to do some chess programming. I'm a professor at Tufts University. I do artificial intelligence research, and one of my hobbies I do for fun is like play chess at a very average level. And yeah, for fun, this one summer project I think I'd do is to do some programming with chess, try to incorporate some concepts from artificial intelligence in and do some practice with programming. Okay, so let me just get started. So I have some files here, and I got started a bit a few days ago. Well, 17 days ago is when I first started this. Yeah, it's been a busy semester. So I have something very basic here, which is just let's say simple visualizer for sorry, I shouldn't say it's visualizer. I'm borrowing the Python chess library, and that has pretty good implementation of drawing chessboards, keeping track of the data structures for chessboards. It has some support for engines. I don't know them very well, so I'm going to learn them as I go. For now, I'm just going to do something kind of simple and probably the wrong way to do it, but it's a start. What I've built so far is just a simple, test rig. It's not ideal. I wish I could make it nicer, but I'll learn more about how to do this a little bit better as we go. So I have this. I import a PGN from a game I played a few weeks ago. Just a game. I think it was. Was this against I think it was against a person. I think it was an actual online game. But it was a situation where I was, winning in an end game. I think let me just run this. If I run this code, this is the position. Was I white? Yeah, white must be winning here. White is the queen. Yeah, so this might be a nice test situation to see if I can write an artificial intelligence engine that can win from this position. I mean, not any, but most players can win at this, from this position. The white is up 11 points of material, so should be a easily winnable position. But for an engine that I'm going to try to write, I'm going to try to spend half an hour in this stream. So if can I write an engine in half an hour that will be able to win from this position? Not sure. Okay, so I have here, this is some code I wrote to play a simple game, and the way it works is oops, what happened? Okay, so it displays the board, it plays a move, or actually it just, okay, so I have this function play game, which I put in here, this utility function. It takes in two player objects and then just calls each player back and forth. Whenever it's the white player's turn, that player makes a move. Whenever it's the black player's turn, that player makes a move. So pretty straightforward if statement to check whether the turn is the white player turn, and if it is, then the white player moves, and so on. And it just runs us until the game is over, and doesn't even check who wins. It's up to us as the human to just interpret whether we won or not. Eventually I'll actually program it to encode who's winning, and then we'll be able to do some smarter artificial intelligence with it. But for now, it just plays the game. And the way I called it in this cell in this Jupyter notebook is I called it with a console player as the white player and a dummy engine as the black player. And dummy engine is just an engine I created here, which does something really simple. So the interface I designed, I put that in quotes, the interface I quickly designed for an engine is just that it's an object that takes in, or that has a play function, or play method, that takes in a board that comes out of the Python chess library. So it's a board object, and then it just lists all the the engine interface is just going to return a move. So it takes in a board and it returns a move. In this case, it takes in a board. This is the dummy engine. It lists all of the legal moves. So here is this is a Python, what do you call it, attribute. So it creates a generator for all the legal moves. And I just create a list out of those and randomly choose one entry from that list. So dummy engine is, I guess, the bare minimum chess engine that all it does is find the legal moves and makes one of them. So at least it chooses legal moves. Great. Okay. So my goal is to build a better one. So also console player. Console player is another thing. Another engine I created. It's not really an engine. These aren't engines. These are players, I suppose. So console player comes from. Oh, I don't have it open. It's another file. This is console player. It just takes the text input. I think this is, what is the name of this format? This is UCI. This is UCI format. I don't know what UCI stands for. Universal Chess Interface. Okay. Yeah. So but whatever. It's just you code in the names of, or you type in the names of the squares you want to move from and to, and then if you promote a queen, you have to add the letter symbol for what move you want to, or what piece you want to promote it to. But otherwise, most of the time it's just the moves. Like even if it's a capture, I think you just type in the actual squares you move from and to. So it's pretty straightforward. I'm decent at picking up grid locations quickly, but I'm not that great. Not as great as all the other great chess streamers out there. Okay, so yeah, it does check if it's a legal move, and then if it's not a legal move, it'll return the move and then continue. So that's what's happening here. So now what we see is the dummy engine looked at this position and identified what are legal moves, and it found what are the legal moves here. It could have chosen between there. Is that it? Oh, it could have blocked, but yeah, okay. Yeah, anyway, so it randomly chose this one. So now it's our move, so we can enter in something. Let's take that bishop. So D8, C8. Okay. All right. So then we made a move, and then the dummy engine made a move as well. So okay, this move showed two things at once. So first is the result of our move, and then the dummy engine was in check. So dummy engine moved there. Okay. So that's the setup. We can also quickly change. I think in the next cell, I have dummy engine play against dummy engine, starting from an empty board. So this line creates an empty board, and this is the whole sequence of moves that of two players playing completely random moves. Did the game actually end? It ended with a draw. Okay, so here's new board, random moves. All right, pretty good opening move. Not so good response, and so on and so on. And then they just play random legal moves. Eventually, I wonder how many turns this was. Does it say? I don't think I list how many moves it is. Looks like it was a lot of moves. This is a long game. Wait, was this really? Yeah, it ended up being king and queen against king, and then it ended up being a draw. Okay, yes, that happens. That might happen with the engine I write today. All right, I've used up a lot of time. We don't need this. This was just checking. I was just checking how the board is represented. Something I wanted to do was output the games as PGN files, but I haven't figured out how to do that yet. I can do that offline, not during a stream. That's probably not too exciting. So the more interesting thing is, let's try to write an engine that makes a slightly smart move. So the first thing you learn when you learn chess as a kid is the piece material values, right? So why don't we build an engine based on that? Sorry, I'm getting distracted. Okay, let's try to do that. So to do that, I'm gonna just write. Just give me 1 second. Okay. All right. So I'm just going to create a cell where I'm going to play. Let's see if dummy engine. Let's do the same thing. Would you actually? Yeah, let's go back to the original position. So this was here. So I want to open. Oh, this is a little ugly. I'm going to copy this whole thing. And I will generate. This pulls up the game that I had before where I was winning, and then I will now play the game between dummy engine and I called it, I just created a stub for a score engine. So I'm going to do dummy engine and score engine. Oh wait, hold on. Score engine is white. Yeah, okay, so score engine is white. So because white is winning, I would hope that score engine, because if I make it smarter than dummy engine, should be able to, checkmate the king in this position. So I'm going to start by just like trying to, will score engine even work well? If it's just trying to maintain material or improve, have the best material count, yeah, it'll probably do fine, right? So like in the next move, it'll probably try to take the bishop, or it'll try to eat up some pawns. So yeah, oh wait, hold on. I totally didn't notice. I forgot this game happened weeks ago for me. Yeah, this is actually not. So when the king moves out of the way, it's critical that we take this pawn. Okay, well, we'll see what happens if score engine can figure that one out. So right now this is score engine is just a copy of dummy engine. So let's think about this. So what we want to do is we want to count up. Let's just start with a score equals 0, and we'll just start counting up the pieces. Oh, that's not how we want to do this. So we still want to get the list of moves, and now for each move, we want to think about what happens next. So if we think about how, yeah, so this is where we have to look at the API in Python chess to figure out what we want to do is apply each move to current board and count material. And one of the tricky things is we have to decide what color we are. So let's say by default we're the white player. So that's oh, I have to set that. I have to save that somewhere. So self dot. What's the most modular way to do this? I think if we set it to import chess. I'm also doing this in Jupyter Notebook, which is not my favorite development environment, but it's easier for screen sharing than screen sharing in IDE and then switching back and forth. I want this viewers to be able to see when I look at the documentation. So anyway, self.player, let's set that to chess. Let's see if I remember what this is. Let's see, chess.white, white, black, chess color. I guess let's say chess.white. If white, else chess.black. Let's do that. That's actually just true and false, but let's be or what's the word? Let's follow the API, because they could change that at some point, and then we can be portable. Okay, so now we will. Still something tricky here about how we do this, because we'll count out the material difference, and then we will have to decide whether, if we're white, then we want it to be, in favor of white, and if it's black, we want it to be in favor of black. I wonder what the best way is to do that. Maybe we can just identify the pieces by, yeah, we'll have to see how the pieces are stored in the board. So let's see. So why don't we say, let's move this down here. So this is my note. I'm just going to count material. So now that we've applied, let's see how we would apply the move. So if we apply a move, I know that you can push on a board object. You can push a move, and then we can pop it, I think. Is it a good idea for us to do it that way, or should we create a copy? So push will update the position, and then we can pop it. That's fine for now. I'm worried about later, like later that it might be bad to have it like keep working on the same copy of the board. In fact, modifying this board in place seems a little worrisome. Maybe we can create a copy. I'm gonna do that. I don't feel safe modifying a board that is passed into this function. That's not a good programming form. That could lead to some side effects and create bugs later on. So let's see. Is there a copy root? Returns a copy of the root position. No, I don't want that. I want mirror, mirrored copy. Oh, interesting. Okay, creates a copy of the board. So I just take copy, I think. Okay, so let's try that. Copies defaults to copying the entire move stack. Let's try it. See if it works. So new board equals board.copy and new board.push move. Okay, so now let me just change this documentation. The current candidate to move, and then count material in the new position. Okay, so we've run one legal move, and now we want to count the position. So how do we count the pieces? Let's see where that is. Pieces, baseboard, pieces. So this is the chess piece object, so we can get symbol, that's helpful. Piece color. Yeah, so so we have piece color, and we have symbol. So this actually works. If we can just get a list of all the pieces on the board, that would be great. So how do we do that? So in chessboard, legal moves, reset board, clear, remove piece set piece set, checkers is checked. Push, pop. So they're just moving. Those are just pushing moves on. Then castling, piece map. See, piece map is almost what we want. I was looking at that. It's some kind of maybe that's what we should look at. It sets up the board from, oh sorry, that's setting it up. So this is piece map. Gets a dictionary of pieces by square index. That'll work. I think, yeah, that'll work. It's not, if it feels a little like a hack. Here's the hack, right? So if I can get the pieces. So all pieces equals new board dot, what is it called, piece map, piece I before e, piece map dot items, no, not items, values, because I don't actually care about the positions for this. I don't care about the positions for this type of engine. So okay, let's just try this out. So let's just say print all pieces. Yeah. Yeah, let's try that. So right now this won't do anything. It's still using the random move. But if we try it, we should see it print the moves. Let's try. I don't like the idea of this. This is going to print out a lot of stuff. So let me just play a move. How do I do that? I don't remember how to call it. Play. Oh, alright. Okay, I just need to go like this. I just go like this. So I'll just comment that out for now. And just as a hack, we'll go. Let's do test and engine equals score engine, and then let's just say, what do I call it? White equals true. Why did I write it as, okay, that's fine. It'll work. And then, yeah, I gotta just write stuff and then refactor later. So test engine.play board. Let's see what happens. All right, crashed. Score engine is not defined. I have it. Okay. Okay. Gotta import it from score engine import score engine. Okay, it's imported. Okay. So we got a dictionary of values, the piece from symbol, what is from symbol? This is all the data about each of the pieces? No, why is this showing? Oh, this is, okay, I see. So each of these lines is a printout from one of the candidate moves. So I guess there's 1, 2, 3, 4, 5 candidate moves. And for each time it printed it out. Now I don't know what the from symbol means. Let's see what that from symbol. Why would they call it? Why would they name the function that? From symbol creates a piece. Creates a piece from the piece symbol. Okay, I don't know why they made the printout that way. I guess that means that you can run that line of code and you get an object of this kind. So in either case, we can see the piece type now. That's what we want. Piece type symbol. Let's just do symbol, because type sound. I don't know what data type this is going to be. So this is going to be easy. So PN. It's a pawn, knight, bishop, rook, queen, king. Okay, sounds fine. Let's go to this. Let me close dummy engine. I don't need console player either. All right, score engine. All right, so now. For piece in here, let's do material count equals 0 for piece in all pieces. Pieces. And why don't we create? What's the right way to do this? Can I make like a static? Let me make a static dictionary. So let's say piece values equals, okay, pawn 1, okay, knight 1, just heard some thunder, about to be hit by a thunderstorm, bishop. Well, why did I write 1 there? 3, and I can do this. Rook 5, queen 9. I guess for this I'll just write 0. I don't want to make it infinity because then we won't be able to add them up. Did I miss any pieces? Pawn, knight, bishop, rook. I don't think I missed anything. All right, so I think we can just do if piece.color equals self.player. I hope that works. Okay, let's see this. Value equals piece values piece dot symbol, and then material can't autocomplete. Material count plus equals piece value. Material count plus equals minus equals values. All right, so what I'm doing is I'm checking if the pieces are the same color as the player, we get plus the material value. If the piece is the other color, we get minus that value. And then we should get I lost track of all the spaces. Let's just print out the material. So, again, I'm not using a proper development interface, so I'm just printing stuff out. And I guess maybe I'll print the move and material count and see if that works. If that does, then we'll be actually reason about whether this is correct. So let's look at this. I'll run that, and it crashes. Great. Piece value is not defined. Oh, okay, I have to properly name this. So maybe this needs to be self.pieceValue. I actually don't know how to access like a static, like that's just like a constant. I don't want that to be like reinstantiated every single time there's a score engine, but it's also a small dictionary, so it's not too expensive. B, key error B. Oh, that is so annoying. Okay, I think we are dealing with lowercase symbols. I'm not sure. Oh, or is it light colored dark? There's a light squared bishop and the dark squared bishop. Let's see. So the symbol returns this, or lowercase variants for the black pieces. Oh no. Okay. Okay. Right. I missed this. So the black pieces are lowercase, the white pieces are uppercase. Does that help me? No, I don't. That doesn't help me. I'm just gonna do upper symbol. Oops. Symbol. Piece symbol. Dot upper. Does that work? I don't know if that's the right command in Python. Let's try it. It worked. Okay. Let's see if this is correct. So these are the different candidate moves. The material value is the same for all of them. Is that correct? So D5 is the king's current square, and no matter where the king moves, it's not going to change the material count. No matter where the bishop moves, this is the bishop blocking, the C8 D7. C8 D7 is up here. The blocking doesn't change the material. So okay, so far it's correct. And did it add up the right number? Let's see. 3, 4, 5. What happened to the 9? Oh, sorry. It's a minus. Okay. So we're looking at, this is currently no, we must have it backwards, because this is black's turn. So it's black's turn. So we should be 1, 2, 3, 4, 5, 8. So 8 total material minus 1, 2, 5. I can do this. 14. So 14. What did I say? 8 minus 14. So it should be like minus 6, right? Did I do it wrong? I must have had it backwards. So it's self.player. I said it's, oh, I see. I said it's a white, but it's not really white's turn. Oh, you know what? It doesn't actually matter whose turn. Okay, yeah. I have it saved as if you need to know whose turn it is. I mean, whose move it is, but you don't. You don't need anything. So there's no initialization. Instead, it's going to figure out the current turn of the player. So it's actually going to be board. This is tricky. I want the original board's current player, which is board.turn. Board.turn. Okay, now it should work. And crashed. The white. I don't need the white. I don't need this anymore. That's this. Okay, good. -6. Good. Excellent. All right, now, okay, we're almost done. Will I really finish this? Okay, let's see. Don't get ahead of yourself. All right, print. So we're just printing that score, but now instead, what we want is to find the best score. So the way we set it up was a higher score is better. So let's just do, again, this might not be the most Pythonic way to do it, but let's say best move equals none. Best score equals, shouldn't do 0, we should do -infinity, but I always don't like being ugly. Like, this is ugly, like I want to write something like that, but technically I don't know, I guess you can't have a score that low, so that's fine. I'm gonna, it's fine. is not ugly. I don't like stylistically doing this. I don't know if anyone else has this problem. Hi, Secret Mud. Thanks for saying hi. So yeah, what I'm doing some chess programming. I guess we have 2 viewers now. It's not many, but right now I'm just doing a basic engine. So it's just counting material. All right, so I want to pick the best one, that the highest value. So the way I can do this is I can say let's say if, oh no, it's going to be in here. If best move is not none. I don't know, can you do is not none in Python? Let's see. All right, so this way I don't have to deal with, I could actually set this to 0, maybe making it a little bit less ugly, but anyway, and so, no, this is bad. I don't want to do that. All right, let's just do it the simple way. So score, if material count is greater than best score, then in that situation we want to store the best move. So best move equals, what are we calling it, move, and best score equals material count. Oops, count. And is this really all I want to do? I guess then we just return best move. Let's see. Okay, so now I wrote what makes sense when I was thinking about how will this fail. Okay, one condition where it might fail is for some reason we never get a score better than -99999. That won't happen. It's ugly, but it won't happen. Otherwise, as long as there's a legal move, I think this will run, because this will happen. I don't know the famous last words. It seems like it should work. So let's see if I can. So okay, I'll just run this and see if it runs. So it picked d5, e6. I guess in this, again, this is a bad test because none of the moves change the material count. So really what we want to do is see what happens on the next move after that. So let's see what happens if we run this, if we play the game. So we're going to play against Dummy Engine. Dummy Engine does random moves. Score Engine tries to improve the material count as much as possible. And let's see. So we started from this position. This is, again, the position I played in a game a couple weeks ago. It wasn't that exciting. As I said at the very beginning, I'm like an average player. But anyway, so this is a winning position. I was up a ton of material. So let's see if Score Engine's able to win. So first move, Dummy Engine randomly moves there. Score Engine then checks the king. Okay, so I didn't see. This is what I mean by not being the best player. I thought you had to immediately take this pawn before it promotes, but I guess you can check, and that works just as well, maybe. But again, I'm just not looking ahead, so this seems a little scary. So Dummy Engine moves king out of the way. Then, oh yeah, here we go. So Score Engine, trying to get as much material as possible, gets a free pawn, takes it with check. Cool, that seems good. And then Dummy Engine steps out of the way, and I'm guessing Score Engine will take this other free pawn. I don't think there's any other. Yep, good. And then Dummy Engine tries to run for it. I don't know where, but this is an impossible position anyway. Score Engine. Now let's just you might have already seen it. I didn't actually see what the next move is. So let's see, what would Score Engine do in this position? Probably take this pawn. That's the only way to improve the material count. So let's see. Yep, did it. That's good. Dummy Engine randomly moves that pawn. Cool. And then score. Oh, whoa. Oh, okay. Yeah. Okay, safe square. At first I thought. Actually, yeah, Score Engine could be susceptible to that, right? Like if this wasn't a safe square, Score Engine still might have taken it because it would reduce improve the material count for that next move, and then suddenly be without a queen. Still a winning position, but not the best strategy. But no, luckily it was a safe move, and so, oh, this is so long. I'm guessing it's not able to checkmate. Ah, yeah. So okay, Okay, so we can work. Could work through every single move like I was just doing, but it seems to be working. And one of the things that it fails at doing is that at the end of the game, when there's no way, there's no longer much to do with improving the material count, or at least without looking ahead. It's just confused. It just plays random moves. Right. So score engine just plays random moves. At this stage, like it's up a queen, a knight, and a pawn. It loses the queen. It loses the queen because there's a random move. The material count's the same as it is at, moving here in the next turn, and then loses the queen because that's the only legal. It's not even the only legal move. We just got unlucky. So let's see. What was the actual outcome? I mean, not that it matters. So this is obviously the flaw in a purely material-based engine. Should I go? Does this game actually end? How did this game end? Was it some kind of maximum move count condition? I don't know if the Python chess rules. Oh wait, or was it stalemate? No, it wasn't stalemate. They just stopped. Yeah, it must have been a maximum move count. Okay, so I guess what I planned to do, I succeeded at, but it's not very good. But it would be okay. Let's try playing against this. Actually, I can actually just try playing against it because this will certainly do better in the opening and middle game than in the end game. I mean, in the end game, when there's no material differences between different moves, I mean, this is obviously a winning position, but it can't look ahead, right? 1, 2, 3, 4, 5, 6 moves to get any change in material. So it can't look ahead. So that'll be the next session. I guess I'll start working on look ahead. That'll get to my some of these lessons I've taught in AI classes on minimax algorithms or alpha beta pruning. Maybe we'll do alpha beta pruning. I don't know. I'll decide later. But yeah, let me just try playing it in the opening. So if I just run this against console engine, so do I want to play as black? No, I want to play as white. So I'll have score engine be black. Console player is what I called it. Oops, what happened? Alright, so here's our game. Wait, what happened? Oh, whoops. I want a new board. Board equals chess.board, I think. Nope. What is it called? How do I do a new one? Capital board. Yeah, to get a new board object. Okay. Alright, so our move. I only know how to I looked at my chess stats the other day, and I've never played anything but e2, e4. Okay, so yeah, so no material difference between a lot of any opening move. So score engine just plays a totally random move, and that is not a good move. So why don't we try to exploit it? We're gonna beat this score engine pretty easily, I think. But just take the center, I guess. So d2, d4. Okay, I feel really bad doing this, but I think I want to take the knight. Oh, my engine. I feel so bad about my engine. Alright, and I'm really bad at grid numbers, so I apologize for this. So we're looking for h6. Alright, so, okay, it took back, which is good. That's what it should do, because, it didn't want to lose that material. So, good. Alright, now, let's do, I don't know, let's just develop G1, F3. Whoa. Oh no. Okay. Right, because it doesn't know what happens next, it thought, oh, a free pawn. Right, so it removed the pawn from my board, and now I can take it back. This does not feel good winning because I wrote this program, but I have to do it. So F1 G2. Okay, that was a random move because there's no material gain. Oh, it's just gonna take that pawn even though it's defended twice. I'm so embarrassed. But okay, so that's what this is what we get for aiming for such a simple first AI. So first off, it was unable to win from that position that I wanted it to win from, and then second, in the opening, it's doing really dumb things because it doesn't know that I get a turn after it goes, right after it makes a move. The other player gets a move too, and it doesn't know that. So I wonder. Yeah. So like the next step it would be, well, the next step is look ahead, which we can do in the next session. I guess I have to get going soon. But yeah, that's it. So I won't continue this game. We're gonna, well, okay, let's just win the game. I think we should be able to win the game pretty easily. I'll just castle. The problem is I'm so slow with. All right, why don't we? I'll probably take with a knight. F3, D4. Random king move. Okay. Okay. What's the fastest way to win? Knowing that this AI doesn't know how to play chess or doesn't know the rules. Probably can try to checkmate. Probably try to checkmate on. Is the fastest way? Oh, I can move the king out of the way. Okay, I'm gonna do something really dumb. G1 H1. Okay, and then F1 G1. Let's move the. Okay. Yeah. All right. Well, this is going to be silly. Yeah. So I do artificial intelligence research. I do machine learning. My research is on machine learning. So I'm not, eventually I want to do some machine learning to actually learn a chess engine. And there's a lot of cool things out there. I don't know if you've seen Maya Chess. Maya Chess does. They try to learn to play like a human, and then of course there's like AlphaZero and AlphaGo. Those have tried to learn to play like computers. Which is all very contrasting with like what I'm doing here. This is just like this stuff is like the very first step toward what basically Deep Blue was based on, which is just like smart look ahead, knowing the value of positions. It wasn't doing any learning. It was just sort of hard coded. That's what we've been starting with, and eventually, like I said, I want to do some actual machine learning where it can kind of learn the piece values on its own, or even the position values on its own. All right, I'm gonna try to set up a simple checkmate. So D1, G4, and then let's get the bishop. Oh, that was actually a good move. I didn't expect it to. I didn't expect it to actually do this. All right, well, I wanted this to be easier. I'm gonna move back. It's a different strategy playing against someone that a bot that has no idea what it's doing. G1, G2. All right, now I can get that queen in position. D1, G4, and checkmate. I think, yeah. G4, G7, and the game ended. Good. Okay. Well, the code works. Yeah. So that's it. That's all I want to do today. Thank you for the 2 people who joined. But as I get further into the engine building, I'm sure it'll be more interesting. Right now, it's just like obviously the least interesting, almost the least interesting engine you could have. And I also try to improve the interface as we go. Right now, obviously, like typing in the grid entries is, for some people they can do a lot faster than I can, and so it can be a little more engaging. But ideally, we can have like a graphical user interface, so I can just click the pieces like normal. But otherwise, okay. Thanks for joining, and I'll probably post this on YouTube and continue posting this as a series. It's my summer project. Hopefully it'll be fun for all of you. It's fun for me, so I'll just keep doing it anyway. All right. Cheers. Enjoy. I'll shut off the stream now.